Well, hello, calculus. Let's do some U substitution with e's and natural logs. All right, looking at number 3 here, we are usually when we're doing U substitution, we want U to be the denominator, the inside, or the exponent. So we're going to let U be the denominator. So we're going to let U equal 2x squared plus 3. That makes the derivative of that. So du is 4x dx. And then before we just solve for dx, we're going to go ahead and look at what we have in our integral here, and we know that this is going to be u. And when we see that, we have this x up here that we're going to have to get rid of. And so what we're going to do in the blue there is just solve for x dx. So we're going to divide by 4, so 1/4 du is x dx. So in place of x dx, we're going to put 1/4 du. And then we're going to rewrite this integral. So our constant, we have a 3, we have a 1/4, so 3/4. And we're going to write this as 1 over u du. Now we could write it as 3 over 4u, but we want to leave our constant out front. So once we have our integral written, we are going to actually take the integral. So we're going to leave 3/4 out front. The integral of u is natural log, so natural log absolute value of u plus c. And then, of course, we have a u answer, but an x question, so we need to go back and we need to change our, replug in our x. So we have 3/4 natural log absolute value 2x squared plus 3 plus c. And there we have it. All right, number 4, once again, we're going to let u equal the denominator. And so u is 1 plus tangent x. And so this is going to be our u. And then hopefully you're starting to see that we have this extra x squared on the, or secant squared on the top, which is great because du is secant squared x dx, which means I'm going to get to take secant squared x dx, take that out, and put du in its place. The entire purpose of u substitution is taking out all the x's and putting everything in terms of u. So what do we have here? We have 3 over u, but we're going to write that as 3 times 1 over u du. U substitution typically really simplifies things. So the integral here, we have 3 times natural log absolute value of u plus c. And then we need to plug our x back in. So 3 natural log absolute value 1 plus tangent x plus c. All right, looking here at number 5. So if you're unsure what to make u, you just kind of start and hope it works out. So u, we're going to let that be our exponent, negative x squared. And so if we know this is going to be u, we do see we have this extra x here that's hopefully going to go out with our du. So du is negative 2x dx, which is great because here's x dx. And so I need to get this x dx by itself so I can substitute in. So we're going to divide by -1, or divide by -2. So -1/2 du equals x dx. So in the blue here, we're going to take out x dx, and in its place, we're going to put -1/2 du. And then we're going to rewrite that all in terms of u. So we have integral, we have 5, we have -1/2, so we're going to write that as -5/2. And then we have a du, and inside we have e to the u. E to the u is one of our favorite integrals to take because it's so easy. Integral of e to the u is e to the u. So -5/2 constant stays out front. E to the u plus c. We don't want a u answer for an x question, so we're going to put our x back in. So -5/2 e to the negative x squared plus c. All right, number 6, again, we might be a little unsure of what to make our u. We might be looking at x squared. But then when you do your du, it's not going to substitute out. So then you try something else. So we're going to let u equal the exponent here. So u is 1 over x. And then du is not natural log, right? The integral of 1 over x is natural log, but we are taking the derivative here. So we're going to go ahead and write this as x to the negative 1 so that we can see it better to take our derivative. So our derivative is negative x to the negative 2 dx. And hopefully when you see that x to the negative 2, you think, oh, there it is. That's my x squared in the denominator. So we're going to divide by negative 1. So negative du equals, and x to the negative 2 is 1 over x squared dx. So we can take our x squared in the denominator, dx, and replace it with negative du. And so we're going to write this as an integral. We've got a negative du, that's our blue, when we take out x squared on the bottom and then dx, and so then we just have e to the u. And so again, becomes a nice simple integral. Integral of e to the u is e to the u, so it's negative e to the u plus c. Need to put our x back in, so negative e to the 1 over x plus c. All right, number 7. We're going to let u be the denominator again. So maybe you were unsure. Maybe you should make it be 2x. And if you're unsure, you just kind of start and see what happens. So we're going to let u equal 1 plus e to the 2x. So this becomes our u, and our problem becomes that e to the 2x on top. But our solution is that when we take the derivative of our u, our du has an e to the 2x in it. Right? So the derivative of u is 2 e to the 2x dx, which is great. That means our e to the 2x dx in blue, and our integral is going to come out. But first we need to rewrite this and divide by 2. So 1/2 du is e to the 2x dx. So in place of e to the 2x dx, we're going to put 1/2 du. And then we're going to rewrite this. So this is integral. I got 1/2. I got du. Then in the red, I got 1 over u in the denominator. And again, we have a nice simple integral. That's 1/2. Integral of 1 over u is natural log absolute value of u plus c. Put our x back in, 1/2 natural log absolute value, 1 plus e to the 2x plus c. All right, number 8. If you feel like you are rocking and rolling here, then I would maybe pause and do number 8 on your own, and then check to see that you got the same thing that I did. So you can go ahead and pause now and work it out. And let's get the answer here. So we're going to let u equal this exponent. So u is cosine x. And then you should be seeing, how am I going to get out the sine x dx? Well, very easily. So du is negative sine x dx. So we need to divide by negative 1. So negative du is sine x dx. So in place of sine x dx, we put negative du. And then our integral is negative du e to the u. Integral of e to the u is e to the u, so negative e to the u plus c. Put our x back in, so negative e to the cosine x plus c. All right, number 9 is a little bit trickier. There are other methods you can use here. We're going to go ahead and use u substitution so that we're consistent. So we're going to let u equal the denominator, x minus 5. So this is our u. And so we should see this x on top and realize that we're going to need to substitute that in. But that does not show up in our du. So our du is just dx. And so we still have that extra x on top. And what we did in the last unit, if you recall, was double u substitution. So we're going to do this again, and we're going to write if u equals x minus 5, then x equals u plus 5. And so in place of x, we're going to put u plus 5. And that's double u substitution. And so when we rewrite that, we have u plus 5 plus 3 over u du. Now this is not quite as easy the other ones have been, but let's rewrite this. So we have u plus 8 over u du. And when you're dividing by a single term, you're dividing by a monomial, you can break it apart. So we're going to rewrite this. We're going to divide each of the top by u. So u over u is 1 plus u over 8. We could write as 8u to the negative 1 du. And then we're going to integrate that. So the integral of 1 is u, not x, because we're dealing with u. So u plus 8. The integral of u to the negative 1 is, that's 1 over u. So this is natural log absolute value of u plus c. And then we need to put our x back in there. So in place of u, we're going to put x minus 5 equals, not equals, x minus 5 plus 8, natural log absolute value, x minus 5 plus c. All right, so that's a double u substitution there. All right, number 10. This is the last one we're going to do. This is a definite integral, so we've got the bounds on there, so that's going to be an extra little step in our problem here. So we're going to let u equal the exponent, so u is cosine x, or cosine t, and du then is negative sine t dt, and we have sine t dt here, but we need, we need to get rid of that negative, make that u. So we're going to divide by negative 1, so negative du equals sine t dt, and substitute that in. So we have the integral 7 to the u, negative out front du. And remember, our bounds are not 0 to pi over 2. 0 to pi over 2, those are x terms. We want y term, or t terms. So the integral from 0 to pi over 2 in the t world, we need to write that in the u world. And since we know that u equals cosine t, then we need, when t equals 0, what is u? So u equals cosine 0. Got your unit circle, that's right here. So u is 1, so we have 1 down here. And then pi over 2, u equals cosine pi over 2. That is straight up at a 90-degree angle, so that cosine is 0, so u is 0. So our bounds are 1 to 0. Now you may look at that order and not like that because it's going from 1 to 0, which is backwards. And so we can flip that, and flipping that changes that negative to a positive, so it's kind of a win-win overall. We get to go in the right order, 0 to 1, and that becomes positive, 7 to the u du. Now, what is the integral of 7 to the u? Okay, that is not power rule. Okay, that is a to the u. Those are our special formulas. So let's write this off to the side. The integral of a to the u du is 1 over natural log a times a to the u plus c. Okay, so we need to go ahead and evaluate that. So the integral of 7 to the u is going to be 1 over natural log 7 times 7 to the u. And we're not going to put plus c because it's a definite integral, so we're going to go from 0 to 1. 1 over natural log 7 is a constant, so that's just going to stay out front. 1 over natural log 7. Plug in 1 minus plug in 0. So 7 to the 1 minus 7 to the 0 is 1 over natural log 7. And then 7 minus 7 to the 0 is 1, so 1. So this is 6 over natural log 7. And there you have it. There's a whole bunch of U substitution problems. Really make sure that you're understanding where to plug in, how to substitute in, and kind of the purpose of the whole thing. And let me know if you have any questions.